Okay, right. So let's we're going to go question 149 to 152 because these all relate to the same sort of area. So we're still in this area of teasing out what the fixed elements are and what the variable elements are, but we have a much more scientific tool referred to as linear regression, which can help us with that. And in the exam, they give you the formula, if you like. And I guess the question again is making sure you understand firmly what would be. I mean, this is the output, isn't it? So here we'd have customers driving the expense of electricity. So we know that we would have this, of course, on the, well, they tell us anyway, to be fair. Some questions might not, so you have to be careful that you're clear as to what the cost would be on the y-axis, because they're independent. This is what's causing it. So this is the dependent variable, and this is the independent variable. This is so what do we have here? So literally, we take these figures. This is sum. This just means this big thing here. Of course, you know that. That's what that is. This what these are. Sum. And of course, B, again. So the relationship really is something that looks like this, right? Where B is the variable cost and A is the fixed cost. So we're told that we've been given the variable cost. We know what B is. I mean, total cost is fixed cost plus variable cost. And variable cost, of course, is the total variable cost of a unit times the total number of units. So that should kind of explain why we have this kind of all these numbers, in case you're seeing them and wondering where they're coming from. But this 121 is very much the variable cost, and that is your B, right? Whilst A is, we're looking for the fixed cost. That's what we're looking for. And this y is equal to A plus bx, where A is fixed and then B is variable. Okay, great. So we have the sum of y here, which is 5. So I'm literally plugging A is equal to, I'm literally plugging things into the formula. Sum of y is 5.63, which is really 5630, because this is in thousands. Yes, 1, 2, 3, 5630. Minus B, which is 1.21, times the sum of x, which is 2550. And I divide all of this by the number of, if you like, issues here. 1, 2, 3, 4, 5. I think we're told, but there are 5. 1, 2, 3. No, 4. Sorry, forgive me. There are 4 events taking place. We have 4 events happening. And what do? Well, simply subtract this. So I have here, I'm going to do this up here now. So this is 5630 minus 121, and this is 5630 minus 3085 over 4. Bang that onto my calculator at once, and I get 636 pounds. So that's the answer. That's my fixed element, if you like, and that's it. So that's how you deal with these, right? Identify what the B is. They give that to you. Add up your x's and y's, and then divide by the number of events actually taking place, and then you kind of get your answer. So this is a scientific method. When I say scientific, it's a formula that's working it out for us, as opposed to us using the high-low method, which is not as efficient, of course. Okay, great. So let's go on to the next one. Exactly the same thing to practice. You do it before me to make sure you're getting comfortable with this whole thing. And I'm just going to quickly what's the word? run through it again. I'm just going to add these guys up very quickly. And here I have 186, and here I have 2,910. Be careful. This is my x, of course, and this is my y. So what do I now have? I will have A is equal to the sum of y, 2910, minus my B is given to me, my variable cost of £5 per vehicle, 5 times, of course, the sum of x, which is 186, right, divided by B number involved, 1, 2, 3. There are 3, if you like, events taking place. So what do we now have? We now have, I mean, you can chuck that all into a calculator at once, I'm sure. You just have to decide how you want to do it. But you'll put all this into a calculator, and you should arrive at 1060. Right? Okay, great. Um, Now, this issue of please revise it. Correlation. We're basically looking at the relationship between two different outputs to see if there's correlation. I mean, a lot of statistics about looking for correlation, causation, finding out reasons why. And if you remember, a correlation that looks like this, the closer it is to 1 is positive correlation, right? We're looking at and if it's -1, it's the other way. So correlation can switch between the two, but they're giving you this information to give you some idea of the type of relationship that we're dealing with here. So there's strong correlation here. And what are we looking at? We're really looking again at this kind of scenario, a graph where we are looking at the relationship between y and x. And this is telling us they've done some work and there is strong correlation. What we now need to find is, they're telling us, well, we'll give you x and we want to know what y is, but we need to know what a and b is, and they've given us the formulas, and they literally are formulas where we are plunking things in to find. So you just have to be really careful. I would almost break this up into a little kind of, make sure you don't get them confused, right? Then we can sort of see what's going on here. So using linear regression, calculate the value of y for a month when x is equal to 12. So let's look and calculate b very quickly. So b, if you like, they tell us b is equal to the number. They tell us there are 5 sets of data that we're dealing with. They have to give all of this to you. So n is equal to 5. So you're looking for that 5 times and exy, and you look here, exy, that's 1533. So I'll just put that in brackets to make sure I don't mix it up. Minus ex is 40 times ey, and ey is 142, divided by 5 again times just ex squared is 418, minus ex, which is 40 squared. So just watch very carefully. Bang all this into your calculator and you should get b come out at 4.05. So take your time, I'm sure you've gotten that already. Then it tells us that to get a, what we now need to say is that ey, so a is equal to ey over n, which is a is equal to 142 over n over 5, minus b, which is 4.05 times ex, and that's ex, which is 40, divided by 5. So do this first, then do this, and you should have a come out at -4. So what are we saying? Y is equal to a, and a is -4 plus 4.05 times x. And so we're told, well, when x is 12, what is y? Well, y is equal to -4 plus 4.05 times 12. And y is equal to -4 plus 12 times 4.05. 12 times 4.05 is 48.6. And 48.6 -4 plus 48.6 gives you 44.6. So what am I saying? Just walk slowly through the formula. Just identify clearly what ex is, what ey is, what ex squared is, what ey squared is, and what exy is. And you're on your way. Okay, great. And this is kind of similar to what we've just been doing. Again, I'm just going to add through. This is asking for a and a, so I know again that this is my x because this is driving this cost, right? So I will, again, here I have 3,300. Here I have 4 plus, here I have 3,564. That's what I have here. Okay, great. So what do I have? So a is equal to the sum of y, which is 3,564, minus b. B has told me at 15p times 3,300 divided by 3 items, because that's what's happening here. 3 events taking place. Bang all this into your calculator, and A should come out at 1023. Right? And that's those questions. So those are the questions on this kind of linear regression, coefficient correlation. Make sure you're comfortable with them as well.